Hello, welcome to my channel. In this video, we are going to learn how jump starting a car works. When we say jump starting a car, it means that a car has its battery down and we need another car whose battery will be used to energize the battery that its battery is down. So we have a circuit that describes the connection between the two batteries and it is given as this. Right, so let's see the values of each voltage and resistors. So we have 6 ohms, 6 volts, 4 ohms, 8 ohms, 2 ohms, and 16 volts. So in this battery, we see that this 2 ohms resistor is the internal resistance of this particular battery. We have another battery here. The internal resistance is given as 2 ohms. So when you do the connection, the positive part of this particular battery is connected to the positive part of this battery, while the negative part of this battery is connected to a resistor before it is connected to this battery. We also have 2 points that we might be interested in later in calculating a particular parameter. Right? So the question that can come out from this kind of system is giving us A, find the current in the circuit. So we need to find the current in this circuit. B, find the potential VAB, the potential between this point and this point. Then 3, find the power in 6 volts battery and 16 volts battery. Now to solve this problem, the first thing we must consider is we must consider the direction of a particular current. We must consider the direction of the current that is flowing through the circuit. So if we look at this particular volt, it's smaller than this. So we assume that the current that will be flowing through the circuit will go in this direction. From negative to positive, it will go because this one will overpower this one and it will go in this direction. That's the first thing. Then the next thing we also need to consider is, so let's see the direction. So the direction is given as this. Then the next thing is when the current flows in this direction, that's a clockwise direction, we must first of all identify the positive and negative terminal of each resistors. So when the current enters this part, that part is described as positive, and if it leaves this end, it becomes negative. So we have positive, negative. We must label all the resistors for life to be easy when we are doing our calculation. So we have positive, negative, positive, negative, positive, negative. So since the current will enter through this direction, here becomes positive, negative, positive, negative, positive, negative. But mind you, for that of the battery, the voltage, the longer part is positive, the shorter part is negative. Likewise, the longer part is positive, shorter part is negative. So for us to now find the current in this loop, we need to apply the Kirchhoff's voltage law, which says that the algebraic sum of all the voltages in a closed loop must be equal to 0. Okay, so we start by saying that from this point, the current that will flow through this part, we call it I. So if the current flows through this part, notice it will move from positive to negative. So it means that there is a voltage drop here. So it becomes negative I times 2. So we have minus 2I, then followed by this. So since we are moving from positive to negative, everything ends at negative. So it becomes minus 4 times the current flowing through it. So we have minus 4I, then followed by minus 6 volt. Now, since we are moving from positive to negative, it becomes minus 6 volts. Okay, we are moving from this point to this point, it becomes minus 8I. Then when we get to this point, we are moving from negative to positive, so it becomes plus 6 volts, 16 volts. Then these are all the voltages in the loop, and everything will be equal to 0. Now that we get this one, we can add all the currents together and all the voltages together. So if we have 4 plus 6, 2 plus 8, everything will give us minus 20. I plus minus 6 plus 16 will give us 10 volts equal to 0. So we can simplify this one to have 10 volts equals to 20I. So if we make our I the Sebian formula, we are going to get I equal to 10 over 20 equal to 0.5 ampere. So this is a current that is flowing through the circuits, right? And because it is positive, it shows that the direction that we took is the right direction, right? Then we go to the next question, which is find the potential VAB. To find the potential VAB in this circuit, we must move from this point B to point A. And what that means is that we need to sum all the voltages you meet on the way when you move from point B to point A. And there are two paths you can take to move from point B to point A. You can follow these paths, and you can also follow these paths. So let's follow this first path and see what the voltage potential difference AB will look. Now, for us to solve it, to move from this point, we notice that this side is negative to positive. So here will be plus 16. The current that is flowing through this times these 2 ohms will give us voltage. And because it is moving from plus to minus, it takes minus 2I. And because we are moving from positive to negative, it takes minus 4I. So in that case, we have 16, which is positive 16, minus 2 times 0.5, then minus 4 times 0.5, and that will give us 13 volt. You can also follow these paths, and let's see how it goes. If we start from this point down to this part, we have from negative to positive. So this one will be plus 8I. This one is negative to positive plus 6 volts. Negative to positive plus 6 times I, and that will give us VAB. So 8 times half plus, we are moving from negative to positive, plus 6 volts. Then this one is negative to positive, 6 times 0.5. So we see that we still get 13. So whichever way you follow, you still get the same voltage, right? So we'll move on to the third problem question, which is find the power in 6 volts and 16 volts. Now, to get the power in these volts, we just multiply the current times this volt. That will give us the power in that particular battery. Likewise, this one. So we have the power in the 16 volts battery is I, the current flowing through it, times volt, which is 0.5 times 16 equal to 8 volts. So for the 6 volt battery, we have current I, which is 0.5 times minus 6 volt, which is equal to minus 3 volts. Now, the positive value, positive 8 here, means that this particular battery is discharging this amount of volts. While this minus 3 volts is the recharging of this particular volts, right? So, if we have this one discharging, then this one is recharging. So if you notice, you have taken minus 3 out of this. So the remaining 5 volt will be discharged into those other resistors. And we can show it that the power in all the resistors in the circuit is given by I times IR. Since this one is volt, all the resistors, if you add them, it will give you 20. So if we multiply, that will give us minus 5 volts. So we see that our 8 volts, which is discharged, is recharging this volt and depositing some voltages. There is a voltage drop in each of these resistors. So this is how we charge a battery that is down, which is also known as jump starting a car. I hope this helps. Thanks for watching. Please like, share, and subscribe. Thanks.